my dear students. Welcome to our chemistry class. How are you? I think you are doing well. Today we are going to discuss about the characteristics of different blocks. Before discussing this topic, we must know about the previous knowledge about the some terms, that is, first one, atomic size, electropositivity, electronegativity, ionization energy, valency and oxidation number. What is atomic size? We know it is the size of the atom. Size of the atom depends on the shell number of the atom and nuclear charge. Next is electropositivity. Electropositivity, we know it is the ability to donate or liberate electrons during chemical reaction. We know how these electrons or why the atom donates electrons. We know it is for to getting stability. When an atom donates electron, it becomes positive charged ion. Therefore, this ability is known as electropositivity. Actually, the metals are donates electrons during chemical reaction. Therefore, this electropositivity character is also known as metallic nature. Next is electronegativity, just opposite to electropositivity. Electronegativity is the ability to accept electrons during chemical reaction. When an atom accepts electrons, it becomes negative charged atom or negative charged ion. Actually, the non-metals accept electrons during chemical reaction. Therefore, this electronegativity is also termed as non-metallic nature. Next one is ionization energy. It is the energy required or needed to liberate loosely bounded electron from the outermost shell. This ionization energy is very low for metals because metals already tends to liberate electrons. Therefore, for metals, ionization energy is very low. For non-metals, ionization energy is high. Because in the case of non-metals is actually not tends to donate electrons, but it always accepts electrons. Therefore, to liberate an electron from the non-metal, the energy is very high. That is, the energy needed for this process is very high. Therefore, ionization energy for non-metals are very high. Next is valency. Valency is the number of electrons donated or accepted or shared during chemical reaction to get stability. Then last one, oxidation number. This number indicates the oxidation state. Here the oxidation state means when an atom liberates electrons or donates electrons, it gets positive charge. Then its state is positive. If an element accepts electrons, it gets negative charge. Then its state is negative. We write the oxidation number by using charge plus valency. Charge means positive or negative. Valency already said, valency is the number of electrons donated or accepted or shared. For example, if an atom donates electrons, it gets positive oxidation number. If an atom accepts electrons, it gets negative oxidation number. Next, we can start our topic, that is characteristics of S block elements. We know S block elements are the elements having last electron is added to S subshell. Last electron is added to S subshell, that element included in S block. S block elements consist of first and second group. This is the figure of S-block elements. S-block elements consist of first group and second group elements. First group is known as alkali metals. Second group is known as alkaline earth metals. Why this name is given? Because oxides and hydroxides of these elements are alkaline nature, that is basic nature. Then these alkali metals and alkaline earth metals show high electropositivity. Because these S-block elements are placed in our periodic table at the extreme left side of the periodic table. Therefore, the atomic size of these S-block elements are very high. Therefore, electropositivity is high, electronegativity is low, and ionization energy is very low. Then, first group elements show +1 oxidation state. Second group element shows +2 oxidation state. That is, first group elements always donate 1 electrons. Second group element always donates 2 electrons during chemical reaction. Do you follow me? Okay. This is an experiment to prove the oxides and hydroxides of magnesium exhibit basic nature. Here we take a piece of magnesium ribbon and shone at the spirit lamp. Then it burns with a bright light. Then after some time we collect the ash of magnesium ribbon. This ash is magnesium oxide. Then some drops of water is poured at this ash and make it a solution. This solution is magnesium hydroxide. This magnesium hydroxide is poured at the blue and red litmus paper. The color of blue litmus paper has no change, but red litmus paper become blue color. This shows the hydroxide of magnesium shows basic nature. We know magnesium is the second group element. Therefore, second group element is also known as alkaline earth metal, because oxides or hydroxides of these elements show basic nature. Next, we can discuss about the p block elements. Which are p block elements? We know elements in which last electron is filled in p subshell, then that element includes in p block. We know in periodic table, that is in modern periodic table, 13 to 18 groups elements includes in p block. Here in p block, we know there is different states elements, then different nature elements are included. Look the figure. This figure represents p block elements. p block elements consist of 13 to 18 group elements. The peculiarity of p block element is this p block consists of gas, solid and liquid elements, and also this consists of metals, non-metals, metalloids and noble gases. Here more reactive elements, less reactive elements and noble elements are in this block. These elements show positive oxidation state, that is metals show positive oxidation state, then non-metal shows negative oxidation state, and noble gases shows zero oxidation state. That is, p block elements consist of positive, negative and zero oxidation states elements. These are the characteristics of p block elements. Okay, then we can conclude our topic, that is the characteristics of S and p block elements. I think you get clear idea about these characteristics of S and p block. Then you write in your notebook, that is list out the characteristics of p and S block elements. Okay, thank you.